So after the array language, let's talk about dependent types and how we can do easy dependent type programming, because in the community, dependent types are kind of considered as something hard to do. But I say it's kind of otherwise. So what are dependent types? We can say they are expressive, they are powerful, and they are practical. And why they are expressive? Because we can use dependent types as kind of glorified assertions. And I will show examples of this. And on the same side, we have to mention that types are just artificial constructs. We taught compilers how to do kind of this typed programming, but types are something that is a modeling tool in our toolbox, and we just improve the compilers. And what we can do with dependent types, we can improve our compilers a little bit further and use dependent types in our everyday programming. But what are really programs? So when we have a program, when we say that we have values, and values are just things that can be consumed by functions or can be created by functions. With a dependent type programming language, we can do the same thing with types. So types can be consumed by functions or created by functions. This is the idea. And why they are powerful? Because we can say that we can define precise constraints to encode invariants to ensure consistency of our solution. So the consistency is way more important than being correct. Meanwhile, when we do dependent type proving in kind of constructive mathematics settings, then we are considered about being correct. But here we can create consistent software, which makes kind of no sense. But the consistency is very important when we change that software. We want to keep that consistency. And they are also practical because we can catch these little things and we can articulate these little things at compile time rather than spending hours at debugging time and finding those inconsistencies. So let's see an example. And just a warm-up. I'm going to use Idris. And this is funny because now we had the Dragon Days. And Dragon Days here, and Idris has a dragon logo. So it was really nice. So I'm going to throw this away. So somebody at the end of the talk will have the lucky owner of this little pet. But let's just use Idris. And this warm-up, what we can say, we have x0, which x0 has a type of integer, but x0 at the same time has a value of 1. So x0 has a type of integer and the value of 1. But in a dependent type setting, what we can do, we can talk about types. So we can say that t0 has a type with capital T type, and it has a value of the integer type. So I let this settle down a little bit. So I give you 10 seconds to digest this. OK, let's move on. Originally, I wanted to give my own examples, but I found this very nice, interesting question on the Stack Overflow. And in the Stack Overflow, this question say that, oh, we can have this always making illegal states unrepresentable in functional programming, and we can write Haskell definitions for this. But this definition here, the author of this question created this very, very questionable abstraction around a book ordering system. But this is like real code from the real industry. So this is a very good example to really show the power of dependent types here. But what we have here, that originally we want to create this ordering system, and here we say that, however, this is perfectly valid in Haskell. So I address this in Idris, address this problem in Idris. And let me try to go for the next slide. Yes, it's there. So just a summary of this, of the previous example. So how we can represent this in Idris, no dependent types yet. So we can have a data which has the side for the buy and sell. We can create the order record, which has also the side, a quantity, and the price. And we can create this tablet of books, let's call it book 0, which has two fields, one for the buy side and one for the sell side. So this is the original from the Haskell example, and here there are two examples for the buy order and the sell order, how you can do that in Idris. And in a general, normal, functional programming way, what we do that we create these predicates on orders if something is a buy order or if something is a sell order. So that's like no dependent types involved here, normal functional programming. But with dependent types, we can push this idea a little bit further, this predicate idea. Because what we can do with a dependent type, then we can say that actually I can formalize that an order was a by order. So if I say this, that here, I can do the pattern match, and I can say I'm creating this type, which is a by order, which is indexed by this order itself, and I can only create this yes by order constructor if I had a by order. And I can play the same game with the cell order. In the example, we had previously this list of orders. I shouldn't do like this, sorry. So we had this list of orders, and what we can do that we can create this simple evidence that if you give me a predicate here, which creates something from an order, and if you give me a list of orders, then I can create this structure which says for an empty list, everything goes. For a non-empty list, that if I had previously good orders and I have a new orders, so if I can create something for this order, then I can create the list itself. And here we have the example for the OK orders, for the by order that we have previously, and actually the evidence that these two orders were by orders. So we can use these structures to improve our original book 0. What we can do here, that we can just simply stuck this book, these constructions, these OK orders into the book construction, and we can simply say that, oh, I have a list. I have a list for the buy side. I have the list for the sell side. But I also have to tell that the sell side I had just sell orders, and on the buy side I just had buy orders. And the next question arises naturally, but how I can really do this? Because if I get an order, how I can really do assess this something as a buy order or a sell order? And here comes the picture, this glorified assertion idea. Because with this assertion idea, that what we can do, we can write a function which gets an order, do the pattern match on the side, and if it's a buy order, then of course I can create just yes the buy order. But if I can't do the pattern match, then I can't do anything, so I have nothing. And if I have this predicate for one order, I can do the same for a list of orders. And what I can do here is just I'm traversing the list, and if I find an order which is not a buy order, then I return nothing. But if everything goes well, then I just really have the proof that all the orders were buy orders. So I'm happy. And I can do the same idea with the sell order side. And of course, at this point, you think, OK, but we write real-world programs. What we can do with if something comes from an I/O source? So how I'm going to really do this ordering craziness, and how I'm going to use this? But that's very simple, because we use functions. So if we have an I/O computation which creates a list order, kind of for the sells, for the buys, I can really simply write my create book function, which says that maybe I can create this book, this consistent book, because first I'm reading all the sells and buys, and after I have to assert them, they were actually buy orders. Because if I don't do that assertion, I cannot create the MK book, because this has the proof obligation that this was really a sell side and this was really the buy side. So this really gives us this very nice thing that we can encode our assertions in our data types. And why this is useful? Because if I change my assertion, because I want to change what is a buy order, then I'm forced to adapt all my client codes whenever I create this book of palettes. So this really forces us to be consistent on all the sides. So whenever we change our abstraction, then this will follow up, and I have to follow up on those changes as a software developer. So this was the kind of the example from the internet. And I'm going to give you 3 extra examples from my personal experiences about these dependent types and how I use them. Yeah, we can skip this. So the first example is basically coming from the SQL. There is a problem whenever we create SQL tables and we write queries for those SQL tables, that they have to be consistent with each other. And there is a really hard problem, like if your SQL table is defined somewhere else, and somebody else also has to be able to change them, and you have to write your SQL queries, select queries, and basically one way to test them is just to run a bunch of test cases and see if something has failed or not. But with dependent types, we actually can make connection between these tables and between the correct queries. And the example for this, so we can formalize this idea using the simple construction in Idris, where we have this table description, which has a name, which has a list of fields, and a list of constraints. And also I'm putting this mock that, of course, this table should be valid. So I should create a valid table somehow. For example, the constraints must respect the field names. But at the same time, because I'm a software developer and I'm lazy, I can just simply pretend that, yes, of course, this table is valid. And I can just postpone that implementation a little bit later. So here, dependent types doesn't really stop you for quick prototyping. So if you don't want to add these constructive proofs, you can just kind of mock them and say, yeah, yes, everything is valid. I'm happy. I know what I'm doing. But if I have this table already defined, I can create another data type, which represents kind of the select query. And if I say that I want to select these fields from this table, and at the same time I have to give the constructive proof that actually the fields are in the table. And also I have to do the same for the filters. So this gives us the nice thing that if somebody changes the table, my compiler, the Idris compiler will reject all the client code which does not agree with the actual table in the old selects. So everybody who changed the table are forced to change the selects as well. And this consistency that we really, really need as software engineers. And if we have the simple query, the OK query, then I can simply render that as a normal select in my code. And the whole idea of reading even the table definition from the outside would work, because I have to implement my assertions that assert the table is actually OK. But let's move to the next example. And the next example comes from the domain-driven design. And the domain-driven design kind of tries to keep the high-level model clear, and we can use that high-level model to implement our low-level state transitions. And this example comes from the Scott Warshin's domain-driven design made functional book. He introduces this order management system where he starts to create about a state transition. And of course, we are software engineers. We immediately jump, yeah, this is a state machine. I know how to handle state machines. I know how to implement them. But with dependent types, we can go a little bit further. And we can say that this state machine actually doesn't really just exist in my documentation, but exists as a code. So I can do this simple definition for the states, and after I can say with the normal valid state transition, like we can define this like what we had done for the buy orders or the sell orders, then we can simply say that I have this valid state transition from the order form to order and so on and so on. But this is just an enumeration. And this is a very nice idea. It's nothing complicated here. But with dependent types, what we can do, that we can simply say that we are actually implementing this state type function, which associates a state with an implementational type from my domain. And from the implementational type could have like hundreds of fields there. And of course, we can do this implementational type for all these states. And after, the next step is when we are writing a function which turns a valid state transition step something to an I/O computation, where here we have the start state, and we go for the I/O, doing some in the I/O monad, and we return some end state. But this is real information. So this is the domain type, which could like have many hundreds of fields if we want. But here we are writing this function as a step function, and whenever we see this, then so we can simply create this as a type-safe manner. So I say that if I change the type for the validate order, then the compiler will force me to actually change the implementation of the validate order here. So we are really connecting the high-level documentation and the idea with the low-level implementation. And here we are creating consistency, because if I have to change the high-level state machine, the compiler will forces me to re-implement the state type and re-implement the step transition. And the last example, coming from another hobby project of mine, which I'm writing a GHC backend for Idris that generates an executable using the GHC runtime. And originally, I just picked the STG representation, and I just copied under the Idris compiler, and I wrote my Idris GHC backend. And originally, I used the STG expression. After a little bit of development, I was able to compile the hello word from Idris. I was so happy, but when I started my program, it didn't work. And after 8 hours of debugging, I found 4 different issues. But the root cause for those four different issues actually was that I did a mistake with the representational type. Probably Simon knows what I'm talking about here. But I did that mistake, but the same thing happened all over again. So I thought that maybe that's a nice idea to really index the STG expression with their representational types. And that introduced a little bit of messaging around the argument list, around how STG transformed the representational type in these expressions. But at the same time, when I did this change, my code didn't compile, of course, because I had so many issues all over the place that it was really hard. It would have been really hard to find them with normal test cases and normal programs. So actually, Idris pinpointed out me like 100 places where I got the representational type wrong, completely wrong. So at that point, I felt like I'm killing bugs with a flamethrower, and kind of it felt like the dragon helps me with his flammable breath there. So that's all from me. That's all from dependent types. And I really recommend to read these. The type-driven development with Idris, the domain modeling made functional, and if somebody really wants to go for dependent types, then it's also a really good read for the programming language foundations. Thank you very much.
All right, we have a few minutes for any questions. We'll have a time for both of you. Don't worry.
Hi, thank you very much for this talk. It's very funny because I give a very similar talk with Haskell and domain-driven design, and I warn the audience not to fall for the temptation of using dependent types for SQL, checking, that kind of stuff. So I wanted to ask your experience regarding this particular point, especially regarding the UX, the development experience with that. At a previous company, we were using the Squeal toolkit in Haskell to have much more type checking happening regarding SQL development, and it took 20 minutes to compile, and several gigabytes of interface file on disk.
Yes. So with Idris, that the compilation time is not that problematic because it has kind of different characteristics with type checking. For the developer experience, that it's nice and easy because when you use dependent types, then you can say that your type abstractions won't be leaking out. You can close the module, you can close the abstractions, and you can't really see if you run a smart constructor that there are actually dependent types lurking in that module. So you can simply create the simply typed API for other parts, but you can still do all the assertion checking in your local module implementation.
Okay, the next question. Next question was around here.
Thanks for a great intro to dependent types. I have a pretty simple question. Do you use it in a professional context, or is it more like research or hobby hacking?
I hobby hacking. So that's the short answer. The longer answer is that I think that this will be the future, and I'm trying to find applications of dependent types in the normal application settings. So I'm not trying to do correctness proofs of programs, but more I'm trying to use this as a tool and hope to use this as a kind of software engineer and not to overdo it. So I'm trying to find a sweet spot where dependent types are actually easy to handle and don't really leak over the places you just do. Like this is a very important consistency in my program, so I have to keep it somehow.
Okay, our time is running out. Please give a round of applause for our speaker.
Thank you very much. And as I promised, who wants to have this?
And we have a winner.